One of the critical skills of chemistry is determining the molar masses. We used to talk about molecular weight, but molar mass is what we're using these days. So this is how to calculate the mass of a mole or millimole of a compound when you're given the chemical formula. And you see a few chemical formulas here on the screen. First, what is the molar mass? The mass of a mole of atoms is the mass in grams that we see on the periodic table. Which is that? Well, as you know, the atomic number is the number of protons. And on the periodic table, that's shown in sequence. So the one right before this would be 26, the one right after would be 28. The larger number on the periodic table is the atomic mass, and that's the weighted average mass of all the isotopes. You should have studied weighted average when you studied the atom and studied isotopes. What is a chemical formula? For a molecular compound like water, H2O, it is the number of atoms of each element in the smallest particle, which we call a molecule. The smallest particle or a molecule of the compound. For example, in water, H2O, for each molecule, and that's that big unit that I'm circling, there are 2 atoms of hydrogen, 1, 2, and 1 atom of oxygen. And this water molecule acts as a unit. You would have a number of other water molecules on the left, right, and above and below. For instance, ethanol, C2H5OH. Ethanol is a compound, and as you can see, it's made up of 2 carbon atoms, here shown in black in the beginning, and 1, 2, 3, 4, 5 hydrogens attached to the carbons, and an OH or hydroxyl group at the 4th bond on this carbon. Now understand please, this is an alcohol, that's why it ends in OL, and the OH or hydroxyl group is not a hydroxide group, making it a base. This is not a base like sodium hydroxide. This is an alcohol with an hydroxyl group OH on the end that is covalently bonded to this carbon atom. Now for ionic substances, the formula tells us the ratio of ions in the compound. For example, in calcium fluoride, which is called fluorite, we have an ionic substance. There's a metal, calcium, and a nonmetal, fluorine, which is fluoride because it's gained the electron from the calcium. So calcium really is calcium 2+, and the fluoride is really F-. These do not come in packages of 3, 1 calcium and 2 fluorine. All the formula tells us is the ratio of calcium ions to fluoride ions. And the ratio of calcium ions to fluoride ions is 1 to 2. You see here what we call a unit cell of the fluorite. Now, you can get 100% accuracy on finding molecular masses or molar masses for ionic compounds. And it doesn't matter whether they're ionic or covalent, you just need the formula. So first you identify each element in the compound from the formula. So calcium chloride has Ca, calcium, and chlorine, Cl. Now understand, this is not the Cl2 that is the green element gas. This just says there's 1 calcium ion and 2 chloride ions in the compound. Then you look up the atomic mass of each element on the periodic table or on a table of atomic masses. And you find calcium is 40.1 grams per mole and chlorine is 35.45 grams per mole. Then you multiply each of those numbers by the number of atoms in the formula and add them up. So the molar mass of calcium chloride is 1 times the mass of the calcium, and here's the 1, and 2 times the mass of the chlorine, and there's 2 chlorines. When we do this, we get 111 grams per mole. Now it's your turn. The technique works again for both ionic and molecular compounds. So let's try a few of these. Get your periodic table and look at these chemical formulas for water, for ethanol, for the purple substance potassium permanganate, and sulfurous acid. So turn this video, or stop this video momentarily, do the work, and then come back to get the answers. Here are the molar masses for water, ethanol, potassium permanganate, and sulfurous acid. I hope you've been successful. Now you should go practice some more.